Gentlemen, show's yours.
So hey, we are beginning this field trip with an excerpt from the work Volcanoes in Eruption by Terry Wright. Imagine that you are in a grove of redwoods, some millions years ago, with strange creatures scurrying around under a dense growth of trees and ferns. Smoke has been sighted coming from the towering volcano to the northeast, and a few earthquakes have rumbled through the forest in the past days, but nothing else is unusual. Suddenly, a puff of smoke arises from the side of the volcano, growing larger and larger in seconds, and towering upward, shooting streamers of ash and bombs of lava outward.
A thundering noise starts, slowly at first, then deeper and deeper as the cloud rises. A shock accompanies the sound, and you realize that the cloud is moving down the slope faster than an avalanche. A wind starts also, and the trees lean towards you, away from the oncoming cloud. You hear cracking of the tree trunks, and limbs are falling all around. You feel and smell hot sulfurous gas. Suddenly, things around you start bursting into flame. The sky darkens, and you are blasted by the wind and tiny shards of ash. Trees are leaning towards you, cracking at the base and crashing to the ground. In an instant, all is hot flames surround you, and the forest is laid out on the ground, trunks pointing towards the volcano. The wind slows down, and a fine rain of water and ash follows the cloud. Small fragments of cooling lava fall from the sky, burying the trees with a blanket of ash.
Then all is still, the violence of the explosion gone, and more ash is falling, smaller now, from a high cloud from the bubbling distant volcano. For days and weeks, the eruption continues, with more layers of ash burying the prone forest. Streams erode the surface, depositing gravel into their channels. Glassy lava flows erupt from domes of sticky lava. For perhaps 1,000,000 years, more eruptions lay down ash. Lava flows, and ash with blast so hot that it is wedded into the hard layers.
So, what just happened here? Basically, Mount St. Helena, which is northeast of here, erupted a few million years ago, and the wave of the initial very violent eruption knocked down trees, and then these trees were covered with the ash from the eruption. Over, for millions of years, more eruptions covered, and the ash made hard, dense layers. And these layers basically deprived the trees of oxygen, which inhibited any possible decomposition, and then, so that's why the trees didn't rot initially. And then, as over time, streams came over this ash, and then the streams, or the water, which is rich in silica, would sink down into the trees and begin a process known as permineralization, which permineralization is when water-carrying minerals, mainly silica, slowly replaces each of the plant cells in a tree or plant or some kind of vegetation, and begins to fossilize it until it's completely almost stone, like this example here. And it depends on the conditions, but this process can replicate the cells so perfectly that it's almost impossible to tell if it's a tree or if it's a rock until you pick it up.
Also, to add, the ash was actually rhyolitic ash, so it was made from the rhyolite rocks.
From the volcano.
And also, if you guys picked up, it said that the trees faced away from the clouds. So, if the Mount St. Helena is northeast, which way do you think the trees face?
They faced away from what?
Faced away from the clouds, which were coming from the northeast. So, which way do they face?
So, if an eruption, okay, you got it.
Yeah.
Can you sit?
I had to think for a while.
Yeah. So if you guys walk around, you'll probably notice that most of the trees are facing southwest.
Or south? East? Southwest, yeah, southwest. Any questions?
Wait, so how many years ago did Mount St. Helena erupt?
It was like 3 to 6, I think it was.
3 to 6
Yeah,
million?
the volcanism in
Right there.
In the Napa area, yeah, 3.4. It's anywhere between 2 and 8. Is pretty much when the volcanism happened.
What was the name of the word that was like it replaces the?
Mineralization with
Oh,
the PER in front of it. Permineralization.
Okay.
Yes. Yeah.
Can you quickly go over permineralization again?
Okay, so permineralization is the process in which a structure or cast of generally vegetation, also creatures like a bone structure, are buried under a specific sediment, in this case ash, which isn't a sediment, but it's buried underneath ash, and it's deprived of oxygen, which discourages bacteria from decomposing whatever it is. So it's buried under ash, and then slowly the water seeps into the ash and replaces fills the spaces between the cells in the vegetation or animal or whatever, and creates it kind of turns it to stone essentially. Yeah. Charlie.
I think that kind of answered my question. That's why the trees turn into what looks like stone. Okay, then yeah.
I mean,
see
it
that.
basically is.
And then
it's
also-
like quartz kind of.
Also, why do the trees face southwest?
Well, so
Because you are.
okay, so basically the volcano erupted, and the blast force from the volcano knocked down all the trees, and the blast force was coming from the same direction. Was hit all the trees generally from the same direction. Here, it hit this force all from one direction and knocked the trees over a specific way, and that's why all the trees are. Does that make sense?
They face which way again?
Southwest.
Southwest,
Because the volcano was northeast.
Yes.
because the volcano is about 20 miles northeast.
And do you guys know why it's called Petrified Forest? Because petrified is a scientific word for fossilization of vegetation. So like trees, plants.
Vegetation.
Bones.
Yeah. So permineralization is like the first step in complete petrification.
And the way it's fossilized is that the pores from the trees and like the plants, they're infused with the minerals that come from like the nearby sources. So like
It's mainly-
lakes,
yeah.
ground,
Ocean even.
Yeah.
Any other questions?
I know
Oh
Okay,
yeah.
so how long ago was this?
it's
Like, from
3.4
here?
million years
3.4
ago.
million.
Gotcha. Okay. Thank you.
Probably a lot of information.
Are the trees any different?
I mean.
Different from what?
Like, has evolution changed them? in
So
any way?
yeah,
Oh.
that's interesting. So these are redwood sequoias, and they're, I mean, this is like, it's weird because they're almost like exactly the same. I'm pretty sure I read. I'm not 100% on that, but
Structurally.
structurally they're very very similar to modern day redwoods.
Yeah, like scientists could tell by the fossils that were left that they had the same design as modern redwoods you can see along the coast.
On the other hand, not to belabor the point, do you guys see any redwoods around you right now? So what did that tell you about the environment back then?
Was it the same or different?
It was different.
It was different. And how would that be different? Like, where do you find redwoods today?
Foggy, like Marin.
Foggy Marin. So it wasn't hot Napa, it was foggy Marin when the petrification happened, which is interesting. You can say something about.
Line was closer.
So yeah, probably. Yeah.
So, is that a rock to people, or is that a tree? What are we calling that?
Looks like a tree.
What is it right now?
Stone.
Benny, is it a rock or is it a tree right now?
Rock.
Okay, it's a tree that was turned to rock. It's a rock.
So it's a rock, right? Is that
Sure.
we're calling
It's
it?
a
But I'm
rock.
just saying it's not like.
I would
Guys
call it a
wanna
rock.
touch it to see?
It is a petrified tree.
Feels like-
That is.
Okay.
Yeah, it's a rock now. Yeah.
When you said rock, I meant like.
Just because every single thing that's been in it has been remineralized,
Yeah,
right?
all the vegetation that was there, if it was like
The structure is perfectly
has
intact.
been decomposed or just replaced.